This is Authenticated Code Execution by Design, or Making Zen and the Art of How I Learned to Stop Worrying and Love the Password for Fun and Profit. Great again. So I think the Who Am I slide really is best used as a way of telling you why I think you should care about my opinion on things. I'm a penetration tester now. I was the Metasploit community manager for several years. I worked for Rapid7 writing Metasploit for several years before that. Before that, I was a security researcher. So I've been on some networks and I've seen some shit.
What's Metasploit?
The question is, what's Metasploit? And it's this Python tool that. Sorry. It was originally Perl. Yes. So what is a First, it's authenticated. So that means that there's some sort of login involved, and that doesn't have to be a password. Most of the time it will be a password, but there are other kinds of authentication too. There's certificate auth, there's key auth, like SSH, as Ed was talking about just a moment ago. So there's lots of things that allow you to log into stuff. They're not always the same. They often have different properties. Sometimes you have 2FA to deal with. But I'm not really super concerned about how the authentication happens. What we're talking about is what you can do with it once you've authenticated. When you have a session, what happens? So first, it's authenticated. Then there's code execution. And I'm going to be a little bit fuzzy on this. Sometimes I'll mean code execution in the terms of like shellcode. Sometimes it's you get to run an executable. Sometimes it's operating system commands. Sometimes it's none of those things, and it lets you like manipulate stuff in a weird way. So I'll be a little bit fuzzy on this, and we'll get to that eventually anyway. And it's by design. So that means that we're using the service in the way that it was intended to be used. It is the design goal of this thing to allow you to run code. And we'll talk about a lot of different things that allow you to do that. This is sort of a grab bag of all of the things that I think are most fun and the things that I've run into that allow you to log in and then do something stupid. So first, before we get into any of that, none of this is meant to disparage the tools we're talking about. Everything I'm going to talk about today is something that solves a problem. A piece of software that serves some purpose that people use to do their work. That doesn't mean that they're bad things because I can log into them and do something stupid. There's nothing wrong with them. They're still good tools and they do good things. So I don't want you to think that I'm hating on these things. I love these things because they give me shells. So why? Why do we want a Intrusion prevention systems can't block passwords. They can't block logins, or otherwise, why do you have the thing to log into in the first place? If intrusion prevention prevented users from being able to log into the system, then there's no point in having the system, right? So IPS can't block regular users from being able to log in legitimately. If you can log in as that user, then IPS can't block you either. And passwords will always work. And I mean this more broadly. I say passwords, but I mean it as authentication. Passwords are somewhat less useful today than they were 10 years ago because of the rise of 2FA, because of certificate authentication, because of other kinds of things that people are doing to secure logins. But I don't care about any of that. Because as Bo and Mike demonstrated yesterday in their talk about Google Suite, 2FA is just more work. Stealing a certificate is just more work. Stealing a key is just more work. It's still logging in. I can still log in as that user, and I don't care how the authentication happened. So authentication is always going to be a thing. There will, as you know, I am not I'm not a person who can read the future, but I don't see a way in which the world can exist without authentication. You have to be able to say, this person has authenticated and proven that they are who they say they are, and they are authorized to log into this thing. Those two aspects of computers will always exist. This won't go away. And passwords are the best form of persistence. I stole this from Mubix. I get all my best ideas by stealing them from Mubix. If you have to use an exploit to get into something, you're setting off all kinds of alarms. There's things that see you on the network. There's risk. There's lots of risk involved with that. Running a payload has lots of risks too. There's potential for triggering IDS. There's potential for triggering AV. If you just log in as the regular user, much in the same way that IPS can't block regular users logging in, they can't get pissed off at you for doing the same thing that regular users do. So now I'm going to talk about some of the individual things that I think are useful in this domain. So first we'll talk about login services, the obvious things that everyone thinks of when you think of the idea of being able to log in and run stuff. Things like Telnet. Telnet is, according to the man page, a direct network interface to login. It's a very simple protocol developed originally in 1975 with RFC 15. So it's been around for a minute. It's one of the oldest protocols. It precedes IP by 8 years. Telnet's been around for a minute. So it's pretty old. And as InfoSec people, we've been telling everyone to stop using Telnet because it's not encrypted. But the concepts of Telnet have lived forever and will continue to live forever. We don't have encryption, and therefore we tell people to stop using it. But it still exists. You still find Telnet on real networks. You still find Telnet on all kinds of embedded devices. It exists all over the place. And what you get to do when you log into something over Telnet depends on the thing, because the protocol is very simple. It's stupid. It just lets you talk to the device. And sometimes that means you get like a raw bash shell. Sometimes it means you get a Cisco shell, or all the various kinds of things that Telnet gives you. But because there's no encryption, we yell at people for using it. And it's super old, and it's like this old guy, you tell him that he needs to quit smoking, but he's been smoking for 80 years, and like, why should I encrypt my lungs now? So then we get the new kid on the block. And this is the older new kids after Marky Mark left with OpenSSH. And we add encryption on top of that. Now, you can't just watch it on the wire and steal passwords and see everything that's happening. Encryption gives you some privacy, some confidentiality, some integrity. You can't inject stuff into it. But more than that, it's a more featureful protocol. With Telnet, you log in, you get whatever the shell is. With OpenSSH, you also get port forwarding. And that's one of my favorite things about it. OpenSSH gives you the ability to tunnel TCP traffic from your local machine to wherever that endpoint is that you're SSH to. And now you can create new packets from the inside of the network on the other side and expand your influence that way. So this is not just code execution. You can run commands. You can upload files. You can execute those files. But you also get network access from OpenSSH. So I love SSH. It's one of my favorite things in the whole world. But OpenSSH is not the only SSH. There are multiple implementations of SSH. There's SSH.com, which you don't see a whole lot anymore, but it does exist. And there are numerous Windows implementations of SSH. And each of them has the same issues. So you can log into it, then you can do anything that the user would be able to do. Then in the Windows world, we have remote desktop, and also known as terminal services. It's a graphical interface that lets you connect to a Windows machine and pull up a full desktop and interact with it in the same way that you would with a console. It also gives you access to network shares on that device. So you can connect network shares on your local machine to network shares on the remote machine that you're logged into with remote desktop. So in a way, it acts similarly to SSH in that you get network access to the environment where the target is logged into. And in Windows 8.1 and newer, you can even use pass the hash against RDP in certain scenarios. The restricted admin feature was added so that you could prevent your login to a remote desktop machine from being used on the other side of that network. The idea of it is that normally when you log into Windows, your credentials are cached and you can use those credentials to log into anything else. It's the single sign-on idea that allows you to traverse a Windows network without having to give your password for everything that you touch. So that is kind of a problem sometimes when you're, for example, a help desk person and you're logging into a system and you don't want the person you're logging, the machine that you're logging into to be able to reuse those credentials and log into more stuff as you. So they added this thing called restricted admin that prevents that. But in doing so, they allowed you to now pass the hash to anything that has restricted admin enabled. And XFreeRDP implements this, so it's a Linux tool that you can use, and you just give it a hash instead of a password, and it works. Super awesome. VNC is basically the same idea, but implemented in the dumbest way possible. It's just pixels. That's all it is. It's a frame buffer. And sometimes it can be passwordless. VNC can let you log in with no password, and then it's unauthenticated remote code execution by design. I love it. And it's also often unrelated to system login. So whereas SSH relies on either PAM or Radius or whatever, and remote desktop relies on Windows authentication, VNC can do Windows authentication, but most of the time it has its own little thing. It has its own authentication. That has nothing to do with your Windows password. You can set it to something else, and people are terrible at choosing passwords. You can't do 2FA with VNC as far as I'm aware. I've never seen a VNC server that required 2FA. And that lets you bypass any 2FA on the system that you're logging into with. Then there's help desk things. Things that sort of replace the simplicity of remote desktop with different kinds of backdoors. Amy Admin is particularly fun. This one was brought to my attention because a whole bunch of scammer assholes were using it as a means of stealing money from old biddies, where they'd call up just random phone numbers and be like, "Hey, I'm from Microsoft, and your shit's owned, and I need to log into it, so I can help you. I'm going to be your support. So log into it and download this tool, and then I'll help you." And help means I'm going to encrypt your thing and ransom your shit back to you. So that's not Amy Admin's fault, but Amy Admin absolutely enables it. All of the other remote desktop-y sort of things work very similarly. Basically, you install this server, the client can connect to it and control the desktop in any way that they want. Sometimes this is even unauthenticated too, if you're lucky. Or unlucky, I guess, depending on your perspective. So then we get to file system access. All of these have been things that you log in and directly do stuff. File system access is more like I just get access to the files. Maybe I can only read. Sometimes I can write. And these are the standards. The big one, of course, is FTP. FTP is all over the place. NFS is still around in Unix shops, although there are fewer Unix shops than Windows in the world, for sure. And WebDAV. Now, getting code execution from file system access relies on a lot of circumstances. So you have to be able to write to certain directories, or in some cases you can read and turn that into code execution. So for example, if you can read SSH private keys, then that converts to code execution in another way. You can transfer that to a different protocol and get code execution that way. In the Windows world, if you can write to System32, you win. If you can write to anything, if you can write to C directly, the C dollar share, then you win. If you can write to any place that an executable loads a DLL from, then you win. And all of those things are very dependent on what the share is giving you access to. So these are the most unreliable things that I'm going to talk about in this presentation. Everything else is you log in and you win. These are you log in and maybe you win, maybe you don't. WebDAV is a lot less common than it used to be. It was around, it was really prevalent back in the early aughties with Microsoft Front Page and the rise of Subversion, the fall of CVS. And now that Subversion is falling by the wayside in favor of Git and Mercurial and all the new, more useful tools, WebDAV has sort of dropped off a bit, but it still exists. You still find it. And WebDAV in particular is useful because most of the time when it's available, it's intended directly to be able to upload system shells. Like that's what it's for. It's the whole point of it. So you can upload new code to the server. Then we've got SMB. And I didn't put it on the previous slide because SMB is a special case. Does anybody know who Ned Pyle is? Raise your hands. Ned Pyle, he's the program manager for the SMB protocol at Microsoft. He's a cool guy, very punny. And I love this quote. It's fantastic. So SMB1 is the older version of the protocol. He's been trying to push for everyone to get off of SMB1 and onto SMB2, which is a much faster, less stupid protocol. And running SMB1 is like taking your grandmother to the prom. She means well, but she can't really move anymore, and it's sort of creepy and gross. But it doesn't really matter that much which version of the protocol you're logging into. If you've got access to SMB1, it's the same as having access to SMB2 in that I can still write files wherever I'm allowed to write files. And Windows has all of those places I mentioned before, but there's more to SMB. There's more than just file system access. So we'll come back to that in a minute. Now I want to talk about some more server-y type things, administration things. Is anybody familiar with Tomcat? I love this thing. Tomcat is an application server, and it has a manager application whose whole purpose in life is to allow you to upload new code. That's what it's for. It's for you to deploy new applications on your web server. By default, it uses HTTP basic auth over HTTP. So it's unencrypted base64 passwords. Sweet. By default, it has a username Tomcat with the password of Tomcat. And in later versions, they removed the defaults. Tomcat, the Tomcat user is no longer allowed to log in by default. But this was just shells for days. And it's not the only thing like this, so we'll talk about some more of those. The next one is WebSphere. Does anybody know what WebSphere is? It's like Tomcat on steroids. The whole point of Tomcat is to deploy on the application server where Tomcat is deployed. The purpose of WebSphere is to deploy to a whole cluster of application servers. So when you own Tomcat, you own the Tomcat server. When you own WebSphere, you own the whole data center. And my favorite part about IBM WebSphere, okay, first, can anybody guess what the default authentication mechanism is? Not you. Anybody guess what the default authentication mechanism is for IBM WebSphere? None. You're right. So the application supports NTLM auth. It supports LDAP. It supports Radius. It supports all kinds of stuff. But by default, logging into WebSphere is clicking a button. It's a button on a web page. You have to give it a username. You have to give it a username. but it doesn't matter what the username is. You can give it anything. And even better, if someone else is already using that that username, it kicks them off first. It's awesome. Then we get to the same idea. So WebSphere deals with application servers, and then we get things like virtualization servers that let you control entire data centers full of VMs. Getting access to vSphere is amazing. It's so much fun. Once you've got access to this thing, you got full console access to everything that it controls. And vCenter is intended to be able to log into multiple ESXi servers. So this could be dozens of machines by accessing this one service. So if you see vSphere, log into it. Proxmox is an open source thing that works very similarly to vSphere. The whole point of it is that you can log into all of the virtual machines that it can talk to. Proxmox can also connect up to, I believe it does Zen, and it does Zen, it does ESXi, it does KVM, and so this is more likely to get you a bunch of Linux VMs, which is interesting in its own right. But absolutely worth your time. If you can log into this thing, I recommend doing so. Then you have all the various cloud things. So I'm just going to let that run for a minute. That's, yeah. So if you get access to Amazon keys, you can log into their AWS and see all the VMs. You can download more secrets from those things. Often getting access to Amazon keys gives you access to SSH keys, gives you access to more machines. So steal all the things. And if you're working in the cloud, it's okay to be sad. The next server administration thingamajig is WinRM, and I love WinRM. It's not enabled by default on Windows, but it's enabled a lot. A lot of people turn it on. And inside any PowerShell session, you can type enter PS session dash computer name and then whatever you want to talk to. If the target machine is running WinRM and you have a valid login for that machine, then you can run PowerShell on that machine. It's fantastic. There's also the winrs command, which will let you run a command directly. So this will be like a CMD command. And both of these things are fantastic. Lots of people have done a bunch of cool work with this. So I'm not going to repeat it too much, but definitely WinRM is one of my favorites. And that leads directly into what I said we were going to talk about more later. Now it's later. And SMB, like I said, is not just SMB. It's a full ecosystem of all kinds of crap. The RPC interface in SMB gives you access to a bunch of weird stuff. The one that everybody knows is the service control manager. So the way PSExec works is it uploads a file, it creates a new service, it points the service's bin path at that new file that it just created. It starts the service, it stops the service, it deletes the file, it deletes the service, and you get shells for days. Now, almost all of the things that I'm going to talk about, you have to have local administrator access to the victim machine. But you can do everything that PSExec does manually. You don't have to use the sysinternals tool. You don't have to use the Metasploit module for it. You can do everything it does manually directly from a CMD shell if you want. And a lot of places don't like seeing psexec.exe on their network. So it's something to keep in mind that you don't have to do that with PSExec. You can do it with the underlying mechanisms that it uses. sc.exe is the service control executable that lets you create services and stuff. And if you give it a computer name, it will operate remotely, exactly like PSExec does. Then there's the task scheduler. @.exe is the way you interact with this. you can use @ to point at a target server. And I'm going to steal Rob's story about this. If you use @ make sure you check the local time of the target system first. They might not be in the same time zone as you. And it really sucks if you tell it to run 10 minutes from now and it actually meant 10 hours from now. So watch out for that. And the task scheduler on older Windows used to go directly over SMB. And the same is true of PSExec. It used to go directly over SMB, and it would talk to the named pipe for the @ service, ATSVC. Same with PSExec. It used to talk to the serve service, SRV, SVC, over a named pipe. Now, on modern Windows, instead, it talks to first the port mapper on 135, and then some ephemeral port on a high number. But it works exactly the same way, and it's all completely transparent to you if you use the executables. So you just use @.exe or you use sc.exe, and they work exactly the same way regardless of what you're talking to. If you have access to SMB as a local administrator on the target machine, you also have access to the remote registry. Changing stuff on the registry is code execution every time. There's the run key, the run once key, which are just things where you put an executable name and it'll just run that when the system boots. And that gives you delayed execution. You don't get your shell right away, you get it when the system boots, but it's still a valid way of getting a shell. There's the debugger keys, which allow you to set a debugger for any executable. And I stole this from Movix too. You can set a debugger for the sticky keys executable, and then when you use remote desktop, you hit shift 5 times and it gives you a shell, or it runs your executable, whatever you told it to. But it doesn't have to be sticky keys, it could be anything. You could set it on explorer.exe, and then the next time someone logs in, you get a shell as them. You can also modify the path by modifying the registry. There's many, many ways of gaining execution by controlling the registry. These are just some of my favorites. By changing the path, you can tell Windows to look for my executables first. You can put a UNC share as the first thing in path, and then it will always go and look at my box for your executables anytime anything runs. App init DLLs. Does anybody know what that is? Show of hands. What is app init DLL? Okay, a few people. Basically, if you've ever heard of LD preload in the Linux world, it works exactly the same way. It's a bunch of DLLs that anytime any process starts that uses user32, it'll load up those DLLs as well. So you get direct code execution in every damn process. It's awesome. Then you get decom objects. These are fun. This is a relatively new means of code execution through SMB, where I believe this was Matt Nilsson, Enigma X3. So mmc20.application is the decom object that controls MMC. So the machine configuration doohickey, the one with all the snap-ins. You can add snap-ins through this decom object, but there's also just an execute shell command method on that thing. So you create the decom object, then you call the execute shell command method on it, and it runs whatever you want on the victim machine. Similarly, Excel.application is Microsoft Office Excel, and that lets you run macros. So anything that you would normally use in a phishing attempt, you can run it directly through this interface. And the best part about both of these is that the services run as system, so it's just shells for days. Yes, Excel does have to be installed, but how many shops have you been on where Excel wasn't on anything? So then some that are not quite so obvious. I love these things. WordPress is my favorite web shell. It's a content management system that I'm sure most of you are familiar with, but that's not its only functionality. And this is the market share according to w3techs.com. Anyway, 59% of websites on the internet that have a CMS have WordPress. 28% of the entire damn internet has WordPress. If you can log into WordPress as an administrator, you have access to all kinds of fun things, like themes. And themes sounds like it's like style sheets and templates and stuff. No, it's PHP code. Because why not? And you can upload themes directly from the admin interface, and it's basically just a zip file containing PHP code in a certain directory structure. And it's super easy to write them. You can get all kinds of examples on the internet. Super easy to use. There's also plugins. So WordPress, and plugins sounds more like a thing that would execute code, right? And turns out, yes, it does. You can install plugins directly through this interface as well. It works exactly the same way. It's just a zip file containing PHP code. There's also like marketplace thing where you can go and download other people's themes and plugins. And there's a bunch of them out there. Some of them are really useful for attackers. There's one called shell.php, which I bet you can guess what it does. Then we get Joomla. And Joomla is not as widely deployed, but you still see it. It's still, so if we go back to this slide, 3.2% of the internet is running Joomla. That's still pretty significant. And Joomla has this extension system where you can upload a file directly, but they also have a market thinger, similar to WordPress. And that uses the marketplace where if you want to create a package, you need a Joomla account, joomla.org account. You need a Git repository somewhere on the internet that it can talk to. You need a key that will allow you to upload your code to the marketplace. And so there's some hoops you gotta jump through. It's all free, and there's no humans involved in the process, so you can sign up and you can do all this yourself pretty quickly. But you don't really need to, because other people have uploaded other things. There's also a shell for Joomla. It's right there in the marketplace. Then we get to Drupal. And you may have detected a pattern here. There's a plugin system for Drupal, and you can upload plugins. It works exactly the same way. It's a zip file full of code. You upload the file, it puts it on the file system, it opens it up and runs all the code for you. Drupal, before Drupal 8, also had this awesome thing called PHP filter. And the people who smiled, I know how old you are. PHP filter is an awesome feature. It's kind of unique to Drupal. No one else really did this. Where if you have access to create content in Drupal, not just as an administrator, but anyone who can create a post, you can filter your post through various things that make changes to it. One of those things is the PHP filter that allows you to run PHP code in your post. So the way that works is it puts the PHP code from your post in the database and then evals it out back later. Now, that's really cool, but it gets better because that leaves the forensics evidence of your code living on the database. There's also a preview feature, which allows you to just eval it directly and it never hits the database. So then it's not even on the disk, and good luck with the logs on that. But again, this is kind of a unique thing for Drupal, and they got rid of it in Drupal 8. But then they brought it back. And I lied, it's not really unique. WordPress and Joomla both have the same sort of thing in an extension. So you can install them all. You can install all of these things directly from their marketplace interface. And these do exactly the same thing. So in WordPress, it's called insert PHP, and it lets you put code in posts. And in Joomla, it's called direct PHP, but they do exactly the same thing. They let you execute code if you have any permissions at all on the CMS interface. So thanks, guys. So then I want to talk about some stuff that didn't really fit elsewhere. How are we doing on time? Oh, I got to go faster. Splunk is fun. It's got a plugin system. The plugin system is just Python code. It's Python code in a zip file. You win. Then they also have external plugins that you can basically give it an ELF and it'll do whatever. Anything you can run on Linux. It supports PAM radius and LDAP for authentication, but if you get the trial version or like the free community version or whatever, no auth at all. It does not allow you to do any kind of authentication. Like that's a paid feature. Yeah. Good times. And then Nagios. I don't actually know what Nagios does other than give me shells. Microsoft SQL Server is fantastic. It used to be back in the old days that if you had an SA account, any sysadmin or DBA account, you could have access to the XP command shell, stored procedure, and you run commands directly through that. And that's cool. That's all well and good. But it's getting a lot more locked down these days. SA blank isn't the default anymore, and you can't rely on command.exe always being there or being allowed by whitelisting, et cetera, et cetera. But you don't need any of that because SQL Server allows you to load assemblies directly. So you can upload C# assemblies and it will load them in its own process, and all of that is completely in memory. Awesome. And my homie Whitey did some stuff with MS SQL a couple of years ago where he was looking at the external scripting interface. That allows you to run anything that the scripting interface is set up to do. And by default, it's not installed, but it's starting to be a lot more common, especially in like the data science world. They're starting to use R for this. And if the R services thing is connected to MS SQL, if you're a sysadmin on SQL, you can run any kind of R you want, which R is a full programming language with access to the Windows API, with access to socket libraries, everything you need. Then PHP-myadmin, PHP-pgadmin, they're not exactly code execution. This is the fuzzy part I was talking about earlier. They're not exactly code execution, but they get you SQL execution. And sometimes that's just as good or better, because being able to read the database is really powerful. Sometimes you find some really stupid shit in databases. I'm gonna get emotional if I get into that. Does anybody remember distcc? You ever heard of distcc? Yeah. It was a build tool intended to allow people to compile Gentoo because Gentoo was trash. And sorry, shots fired. So Jenkins is sort of the evolution of that idea, where you have a build server that allows you to compile stuff and do all of your like continuous integration testing, all of that in one server. And of course, there's a plugin system, and there's a scripting system. And the bad side of the scripting system in Jenkins is you have to use Groovy, which is kind of a terrible language. It's like a dynamically typed Java, which is just the worst of all worlds. So that's totally fine, because Jenkins is a build server. You can just upload make files and run commands. And then I debated about putting this one in the slides. just a little. Now, getting access to Metasploit Pro is not code execution directly on Metasploit Pro necessarily, but anything that you've compromised, if you've got Meterpreter sessions sitting in your Metasploit Pro instance and I can log into it, I can get those too. So it's code execution through authentication to a thing that does code execution. which is kind of fun. So now how screwed am I? How do we defend against this? How do we stop this? As defenders, the best defense, don't be there. Don't run services you don't need. Turn stuff off if you can. Keep in mind that anything that allows a user to log in and run code is something that could allow someone else to run code too. And we've been telling the industry this exact thing for decades. Still doesn't happen. So I'm not really sure where to go with that. Tell it more, I guess. Say it again. Restrict access by putting cats on keyboards. If you can't log into it, then you can't run code. That's the whole point of the. If the thing allows you to run code by logging into it, don't let people log into it. And watch. Pay attention to the logins. Are we on time? Okay, pretty good. So pay attention to where people are logging in, and not just where people are failing to log in, but where authentication happens successfully. Audit all the logins, not just the failed ones, but also the successful ones, because Bob in finance should never be logging into production servers. And there's two ways you can stop that. One, Bob should not have access to those servers. And two, Bob shouldn't even really be able to talk to those servers. You need some segmentation between those two things. Sally in engineering shouldn't be logging into finance systems. She's an engineer. She doesn't need access to payroll. Seems like a no-brainer, but we have to say it. And no one should ever be logging into 100 systems in 5 seconds. If that happens, some shit's wrong. So conclusions. Exploits convert illegitimate access to legitimate access. Once you compromise something, now you're that user. Whoever you compromise, now you're that user. You can use their authentication to talk to anything that they can talk to, and now you're legitimate. Incidentally, if you Google image search illegitimate, you get a gallery of bastards through the ages. And logging in is better than exploiting vulns. If you compromise something with an exploit, there's all sorts of ways that you could get caught as a result of that. If you just log in, there's much less risk. Passwords will always work. I want to reiterate this, that being able to log into stuff is never going away. And you don't always need a shell. So we talked about getting shells and popping boxes and compromising things with passwords, but you don't always need a shell. Sometimes just logging in and stealing the data is good enough. phpMyAdmin is a perfect example of that. You don't need to be able to compromise the operating system on which the database runs if you can read all the data in the database, and that gives you all the credit cards. Think about where you can find this stuff. So I gave you a whole bunch of examples. These are some of my favorites, but this is everywhere. This is not just the things I talked about. Being able to log in and run code is a standard thing for many, many services and many, many protocols. So think about where you can find this stuff and share with the world. What are your favorites? You can find me on Twitter. Oh yeah, and this is Lou Ferrigno throwing a bear. It has nothing to do with my presentation. I just think it's fucking hilarious because he's throwing a bear. Okay, it's the Hulk throwing a bear. Because why not? So you can find me on Twitter. I'm at Egypt with a 7. I have a new email address. Egypt@blackhillsinfosec.com. Are there any questions?
So on recent engagements, I've gotten threads for SQL databases, Oracle SQL. I don't know how to log in.
Oh, okay.
What do you use?
Okay, so the question is, you've got creds to a database. How do you log into it? What do you use to talk to it? So there's a couple of things. I really like Heidi SQL. Rob is a big fan of Navicat. They're both standalone executables that let you talk to a bunch of different kinds of databases. And the best part is they tunnel great over SSH or a interpreter port forward. Anybody else? No more questions? Well, I think we're just about out of time anyway. So thank you for coming.